So in our previous lessons, we were working on graphing linear equations, whether they are in slope-intercept form, standard form, or point-slope form. And so today, what we want to be able to do is now write the linear equations based on different constraints given to us, whether it's a graph, whether it's a table, whether they're giving us a point and information about a slope, or maybe 2 points. So let's review the different types of equations we've been writing in the past. So we started off with slope-intercept form, y equals mx plus b, where m represents your slope, the rate of change. And remember, we talked about the rate of change for the slope being the rise over run, the change in y over the change in x. And so we know that goes here in our equation, and b is representing the y-coordinate for our y-intercept. Then we also talked about equations in standard form, ax plus by equals c. And this is where we said, well, we could turn it into slope-intercept form to graph, but we also found that if we found the x and y intercepts by substituting 0 for an output to find the x-intercept or a 0 for the input to find the y-intercept, those 2 points helped us form the line a lot quicker. We also noticed in the past that vertical lines have equations that look like x equals a number because all of the inputs are that value. Therefore, it's a vertical line and it has an undefined slope. Horizontal lines are written as y equals a number because all the outputs are the same and that has a slope of 0. In point slope form, we're still using the slope here and then one other reference point on the line, typically not a y-intercept because that would just be your slope-intercept form. But remember, you're taking the one coordinate that you have as a reference and you're putting your x value here for the coordinate, the y value here, and it's always being subtracted in the equation. If we saw a plus in the equation like that, that told you you had to subtract a negative number. So just remember that in your coordinates, okay? So let's take a look at a couple of scenarios. Here in number 1, we want to write an equation of the line that passes through the point 2, 3 and a slope of negative 3/4. Well, what do we know? We're given a reference point of 2, 3 and a slope of negative 3/4. We have a point, we have a slope. The best equation to write for this would be one in point slope form because we could easily substitute in the values that we know. So our slope would go here, the x coordinate value would go here, the y-coordinate value goes there, and then we would simplify accordingly, if need be. So let's do our substitutions and see if any simplification needs to happen. So we've got y minus 3 is equal to negative 3/4 times the quantity x minus 2. Everything is simplified as is, so we could leave that as our equation. All right, here's another scenario. Write the equation of a line that passes through the point 0, negative 5 with a slope of 2. So what do we know? We know a point on our line, and we have the slope. We could put this into point slope form again, except this point that we're given is very unique. It has an input of 0. That means it's a y-intercept. So if we have a y-intercept and we have a slope, our best bet would be putting it into slope-intercept form. So if we substitute in what we know, here's our equation, y equals 2x minus 5. Now you could write this in point slope format, but when you simplify, you'll end up getting approximately the same thing. You would have y plus 5 equals 2 times the quantity of x. So if you just subtracted the 5, you would end up here as well. But again, I would suggest if you're given the y-intercept and the slope, go straight to slope-intercept form. Well, what if we gave you a graph? Could you write the equation of the line? So when you have the graph, you want to look to see, can you identify the rate of change and do you know any points given to you? So I can see that the rate of change based on the points I see, the y-intercept and the x-intercept, is going down 2 and to the right 2. So negative 2 over 2 simplifies to a slope of negative 1. Because I know the y-intercept is at 0, 2, I can write the equation in slope-intercept form. That means I would have y equals a negative 1x plus 2. Or if you just want to say the opposite of x plus 2, that is fine. The 1 is implied. Now, we had another way that we could write the equation of the line. Perhaps you wanted to use the point that you saw marked at 1, 1. So again, point slope format could be used. You know the slope, and we're just going to substitute in the values. So you could have y minus 1 is equal to negative 1 times the quantity of x minus 1. There was another point given to you here at negative 1, 3, so if you'd like to use that as your reference point, you could have the equation of y plus 1 is equal to negative 1 times the quantity of x minus 3. Remember, it's a plus 1 because you were subtracting the negative, because your coordinate here was negative 1, which means it's a positive. So again, you had a multitude of ways to write an equation for the same line, just based on what you saw first. All of them would be correct. So what if we gave you another graph? Could you write the equation for the line? So again, you want to look at the graph and see what information do we know. And we can see a point here and a point here. Using those 2 points, we should be able to calculate the slope. So by using those 2 points, my rise over run, 3 over 6 would be 1/2. Now, I do not know the coordinates of my y-intercept because it's not on a grid line, but we use these 2 points to find the slope, so I could use one of those to write my equation in point slope format. So what if we use the first point here on the left, negative 3, 4? We can take the slope and we can take the coordinates of our point and substitute it into our format for a point slope form. And then look at simplifying anything that needs to be. Y minus 4 is okay, equals 1/2 times x minus a negative 3. Well, we know subtracting a negative is doing the opposite, that's adding a positive. So our equation should be y minus 4 equals 1/2 times the quantity x plus 3. Now we could also use the other grid point that we used for our slope, which was at 3, 7. And do the same thing. We could substitute our coordinates into our equation with our slope, and again look to see if there's any simplifying that needs to occur. So we have y minus 7 equals 1/2 times the quantity x minus 3. Everything is simplified as can be, and that would be another correct equation for this line. Now, if you recognize any other grid points on your line, you could do the same thing. You'd have the same slope and just substitute those coordinates into their corresponding parts of the equation. Just remember, if you ever end up with subtracting a negative, that simplifies to a positive. Well, what if I only gave you 2 coordinate points? Could you come up with the equation of the line? Well, if you have the 2 coordinate points, you probably want to plot them on your graph and perhaps form your line. Well, whenever you're given 2 points, the first thing you could find is the slope. And again, looking at my graph too, some of you might want to look to see if you know where the y-intercept is, and we can see that the y-intercept is showing up here. However, it's not a grid line. So putting this equation into slope-intercept form would not be the best choice. So let's find the slope and see how we can use that with one of our points to write the equation. So we know that we're going down 5 units and to the right 9 units, so our slope would be negative 5/9. If I'd like to use the point negative 5, 3 as the reference for my equation, if I substitute them into the point slope format, I would end up with y minus 3 is equal to negative 5/9 times the quantity of x minus a negative 5. Well, again, subtracting a negative, that's a positive, so you want to make sure your equation reflects that. So this would be our correct format. Y minus 3 is equal to negative 5/9 times the quantity x plus 5. Well, we also had another point given to us for the slope, which was at 4, negative 2. If we would like to use that to write the equation of our line, what would we get? Well, we would have y minus a negative 2 is equal to negative 5/9 times the quantity x minus 4. We have some simplifying to do here on the left because subtracting a negative is like adding a positive. So this would be the correct format of our equation. Y plus 2 is equal to negative 5/9 times the quantity x minus 4. Let's try one more. Can you write the equation of the line given the 2 points 5, 4, and 8, 4? Well, again, if they're giving us coordinates, let's plot them on the graph to see what's going on. And connect them to form your line. So we have a couple of options here. We could write this into point-slope format because we could calculate the slope between these 2 points, and we have points of reference. Now, if you notice, this line is unique because it is a horizontal line. If we're talking about the slope of this line, we're not going up or down any to get to the next point. So we're just going over 3 units. Our slope is 0. Now, the horizontal line, we can tell where the y-intercept is at 0, 4. So we could write this very easily into slope-intercept form. And since the slope is 0, we know 0 times anything is 0. And so what are we left with? Just 4. Therefore, we have the equation of y equals 4. Now, if you were writing it in point-slope format, you would notice that it would simplify to give you the same thing. Y equals 4. So we've gone through again writing the equations of the lines, whether we're given 2 points, whether we were given a graph, or whether we were given just a written scenario with some requirements. You're going to practice again doing those items, trying to decide which would be the best format of the equation to use, slope-intercept form or point-slope form.